Go. I have started the recording. This is our lecture for Design 330. It's Tuesday, March 16th, and I think we're in week 9. Oh my gosh. We're really moving along. We have this week and one other, and we'll be finished with our mechanical design process, and we'll have gone really through the whole thing from start to finish, from conceptualization and research all the way through uh, design and production control and all that kind of stuff. So today we're going to do or this week we're going to do mostly, um, I need to share my screen, right? There we go. So we're going to work on the work orders now. So last week we did purchase orders, and that's very important because, of course, you have to purchase your parts, but it also helps us figure out how much it's going to cost to buy the materials for a pump assembly. This week we're going to look at the labor hours, and there's work orders that tell people what to do. It orders the work, and we can get labor hours from that so that next week we'll be able to take a look at the total cost of our part, which will be the last little thing to do, and then we can put together our product book next week. Woo! And that's um, sort of like your midterm. You're going to put pieces of all these submittals together into what's called a product book that a new engineer or a new marketing person or a new designer could grab and learn all about the product very quickly. So let's see what's due this week. Also, I wanted to make sure that you know that tomorrow, no lab tomorrow. I've got one of my family members is scheduled for their COVID vaccine, and I'm the driver. So I will be, and that's a good thing. Hopefully, you all are keeping your eye out on the list to find out um, when you're available or when the vaccine is available for you. And that would be great if we can get ourselves back where we can teach and learn and work in a more kind of together atmosphere. That would really be cool. So no lab tomorrow. I will be unavailable tomorrow. So here we go. This is the what to do this week. Want to look at that first. There is a little preview video that hopefully you've watched. It's only 10 minutes long, and it sort of gives the overview for this week. The playlist does have a few things in it now. And so I went over little parts of the work order. So we're going to talk about these today, but you should really go in. These are more focused about different parts of the work order and how you work with them and how you get the times and things like that. And then I gave you an example, the best I could on one screen. Normally when I do something like this, I've got two screens running and it's much easier, but I was trying to record it all on one screen, but I think it's okay. It's okay. It's not bad. But this lets you know how to make your milling program based on standardized milling commands and your plan. So that's all in there, and you guys are welcome to watch those. I think they're pretty valuable for you to watch. Um, we have a few other cool things in the resource folder, which I just opened up again. Nope, that's an older one. Sorry about that. Let me open up the resource folder. You won't see this one. That's mine that I was working off of, so you don't see that one, but you see a command list, program sample, this and this. Now, some of these are going to go directly into your um, portfolio submittal. And instead of just copying and pasting it in, as always, I want you to do a little bit of annotation. Like if we open this command list, well, there it is. That's it. So there's not much to say. But you could annotate this a little bit to explain what's going on. What is this column? What is this column for? Why is there one called syntax while there's still a command? So you can do just a little bit of annotating to show that you've done more than copy and paste and that you understand how to use this a little bit. Same with this operating times. Now you might add some operating times, but these aren't so automatic. They're a reference, and so when you put this into your submittal, you're going to want to annotate on that page so that it's more than just copying and pasting a chart into your page. Okay, so those are available for you, and I even made a sample milling program just so that you could see. Yours will be much I think I've already got it open. But yours will be much longer than this. Okay, this was just my first, I think, 2 operations. Right? So this is 2 operations and it turns into this. And this is what it looks like when you see the lines of code in a program. This is what it looks like. There's a step number and there's a command, and then sometimes there's a comment. You do not have to put a comment after each one, but it's pretty helpful for anybody who's trying to debug your program. Okay? Especially when you see something like SC5. Well, what does that mean? That means you're using the 25 millimeter cutter. All right? So you're going to actually write code, which is kind of cool. So there we go. Prepare your submittal. It goes into Canvas. You can make an appointment. So that was your to-do list. Let's go ahead and see what we're actually going to talk about. So we're going to talk about today the parts of a work order, how to fill out the work order, and then something that makes, if you feel like it, to do something called data validation that really is a nice thing to be able to do. It's part of Excel and Google spreadsheets, and that's kind of cool. We'll talk a little bit about labor hours, but I plan to do more about that on Thursday. And we'll talk a little bit about the milling program codes. However, I think that your playlist covers all of these probably more clearly and concisely than I will do now. Of course, you got the chance to ask questions now. So that's really good. You can feel free to ask questions. So let's take a look and see what a work order looks like. And I think I have a Jamboard that has a work order copied onto it so that I can kind of scribble and scrape a little bit. Here it is. Here's my Jamboard. So I'm going to move these a little bit out of the way once I start talking about it. But I colored these. Normally, a work order is not colored, but this lets us kind of figure out what's going on. And this is how you would annotate it, but I want a little bit more on what to do. You have to kind of put what goes in each one of these. So let's talk about this blue area first. Okay, and the blue area is kind of about the product. And I think you can see that well enough. I hope that that's big enough on the screen. Let me see if I can. There we go. That's a little bit easier to see. So this blue area lets me know kind of about this work order. Not necessarily about the product per se. It's about the work order itself, but it relates to the product and what you need it for. So there's always something about the product description, however that looks. Words, part numbers, product codes, those are always kind of shown on here somewhere. Now, we haven't paid a lot of attention to that in this class. Our product description has been descriptive, and our part number, our product number, has sort of been the same as the product description so far. But this is sort of like your file name for whatever this thing is. Okay. And a product code is used by accounting to group products together so they can do weird accounting things. They're not really weird, but they can group things together. How much how much money do we spend on blocks? How much money do we spend on springs? How much money do we spend on pumps, making pumps? So, however the product codes are set, it depends on what accounting wants to kind of group things by to find things out. Okay, so that's just something that you would look up in a book from accounting. These go with what it is that you're making, because this is a work order for a manufactured part. It says make this part. And if it's the pump itself, you're going to talk about assembling, pull parts, do this, do that. We're just doing the manufactured parts right now, not the assembly. So maybe this is the block housing, or maybe it's the piston, or maybe it's the intake filter. And they're all going to have some description. There's always some revision that you're going by. Sometimes a product gets revised while there is work out on the shop floor. So it's important to know that, so that if you have two things, you know what revision is being made. Okay. This part is all for timing and for controlling what happens on the shop floor. It's also to find out if the shop is productive or not. So if you entered it on a Monday and said it was due on a Friday and it wasn't done until a week after it was due, you would say your shop is not very productive. But if you entered it on a Monday and it was due on a Friday and you got it done on a Wednesday, your shop is very productive, or it's ignoring some other things that needed to be done first. Okay. So now these dates don't necessarily have to do with exactly how long you're going to run equipment. Sometimes there's a lot of waiting time in here. Okay. So you get this thing entered, but you don't have a machine available for 2 or 3 days. Production control is all about handling these dates and scheduling things and figuring it out in the shop. And we don't have to be, there's so many different ways to do it that it's really impossible to sort of teach in a very short period. They actually have, in manufacturing, engineering, and production and control colleges, mostly in the Midwest, they have whole degrees just in that. Like you're taking design technology that teaches you a whole lot. They have one in production control that teaches you a whole lot just about production control. So we want to know about the dates, and we know that there's a production control guru that's setting all these dates according to some pretty sophisticated, sometimes, programs. Now, you might work in a small shop where your production control is looking out over the shop floor and going, hey, you over there, build this now. That could be your production control. I would guess that that's not very well controlled, but it could be how you do it. So that's the blue section, sort of about the product and using it to track what's going on. Let's take a look at the next part. This is about this order in particular. Okay. And this is all stuff that production control uses to track to help make sure that they get enough parts. They're always worried about, do I have enough parts? If somebody orders 10 of these pumps, you can imagine that you might have 3 of them already built and you need to build 7 more. Well, maybe your experience says, well, I always have to have a few extras on hand, so I'll build 10 more. I'll build 15 more. So there's a number that are required that are still, yeah, I mean, I need this many. And then there's a number that are on this work order to make. Now, sometimes that's because you've got so many that are required, you're going to cut 2 or 3 or 4 work orders because these will get done on one machine, another batch will get done on another machine, and a third batch you might even need to send to a job shop to get done. So this required is always related to how many are on this work order, but they're not always the same. And again, that's the job of production control to figure that out. Says I need this many on this work order. I'm telling worker number 10 on mill number 4 to make 6 of these block housings. Okay. So there's a number that are on the work order. And when it's done and they turn in the work order and they turn in the parts to their shop lead, okay. We used to call them a foreman, but foremen aren't always men. So properly we changed the word to a shop lead. That was back in the 80s that we did that. I still say foreman a bunch because that was the term that I learned originally. But it made a lot more sense to say the shop lead. Pretty soon those will probably be robots. Who knows? Anyway, the shop lead will look at the work order and they'll count up how many completed parts we got and we'll put them there. How many of them are complete? And then out of the completed ones, let's say I made 10 of them and I completed all 10 of them or 6 of them, and some of them are accepted and some are rejected. So complete doesn't mean great. It just means I'm done. I built it. Here it is. And then somebody goes, oh, okay, that one's good, that one's good, that one's good, that one's not. And you're getting some experience with that with your inspection of the parts that you're milling. Okay. And so how many of those were accepted and how many were rejected? Okay. And percent productivity is actually calculated in different ways depending on who is running your shop. Okay. A common way is accepted divided by complete. But sometimes it's accepted divided by how many are on the work order. And sometimes it's rejected divided by accepted, which can be kind of hard because if you have, the other way around, accepted divided by rejected. Because if you reject 0, then you got infinity. So that one's not very good. Usually it's how many were accepted divided by how many were completed. And you're hoping to get near 100%. Okay. And so 5 Sigma production means that you have processes in place to ensure a productivity above 99%. Okay, now not everything wants that, and that's not always desirable. Okay, you could be happy with 50% productivity if you have a huge cost margin on this thing or price margin, and it's just very, very hard to make. So you could have a low productivity and still be happy with it. So part of quality management is to set what the acceptable productivity level is for any part. So that's what this area is about. And it's your shop lead that's really in charge of that. This is such an important person. You can imagine that if this person didn't certify their work properly, or didn't really know what they were doing, or just flat out lied to get a bonus. Yes, I have seen that done. Just flat out lied to get a bonus on productivity. You can see how important the shop lead is. Because if I've got garbage numbers that I'm dealing with when I'm designing and I think things are fine and they really aren't because my shop lead hasn't been reporting properly, I keep making the same mistake over and over and over again. Or maybe not the same mistake, but I'm certainly not driving for improvement. So having a good shop lead that really understands manufacturing and what they're doing is so important. This is a key person in the shop, and they must have incredible integrity. Okay, you just can't do without a shop leader that doesn't have high integrity. Okay, any questions on this so far? Those two were kind of like straightforward, but everybody doing okay with that? Okay, let's get on to the next little part then. And we're not gonna, this part over here is kind of self-explanatory. Okay. If you have a drawing, you need to put the drawing in there. If you have inspection requirements, you need to put them in there. And I think I went over those on the document or on the video. So I'm going to get this out of the way. This is the what to do. So usually there's an operation, and just like in the milling program, there are step numbers 1, 2, 3, 4, 5. There's usually some sort of operation number also. Is this the one I was on? Yes. No, I was on the jam board. There we go. So there's operation 1, 2, 3, 4. Sometimes just because it's easier, whoever's writing these kind of leaves breaks in them so they can add stuff later on. So they'll go 10, 20, 30, 40. So they can put a 15, a 16, something like that in there. But an operation number is just useful for production control. They can track where the work order is. Often when an operation gets done, whoever did it will just scan a barcode or a QR code, and then production control knows that that thing has been done. So it's like, well, where is that work order? I don't know. It's due in 2 days. Where is it? Well, if everybody's scanned their part and you know that it's 2/3 of the way done and there's only 4 hours left, then you feel okay. But if there's 20 hours and there's only, 1 day left, you're going, ah. So this operation number is really just so that production control can keep track of what's going on in an easy manner. And that's all it is. Okay, so you're free to put anything in here on yours when you put it in. 1, 2, 3, 4, 5, 10, 20, 30, 40, 50, doesn't matter. Now there's a place that this operation gets done, and that place is called a work center. And that doesn't necessarily mean it's a specific set of square feet on the shop floor, but often it does. But if the work center is the stock room where inventory is held, then you can imagine if I say go get parts, you would do that in the stock room. Of course, then you're going to put them down out by a machine or something. So this again is sort of up to you, and it depends. Wasan is creating a facility model for us that has a lathe, that has a mill, it has an assembly table. It's got all sorts of things. And there's a manufacturing shop that's got all those things in it. And it's got a testing area and it's got inventory. And I think if I remember, that's the three parts of the shop. And shipping and receiving. And so the work center might just be called the shop. And that's all that stuff out there. Or it could be manufacturing. And that would include the lathe and the mill and the parts washer and all this other kind of stuff. Or it could say the mill. So how you set these up again depends on your accounting and your production control. So again, what you put in here, I'm not too concerned about. But these things that I'm telling you should be part of your annotation on your submittal presentation. The work order is the work center ID identifies specifically where the majority of the work gets done. And then there's a description. Now, sometimes these descriptions are pretty basic. Machine it per the print. Okay. Sometimes they're a little bit more. It's machine it, clean it, deburr it, degrease it, oil it, put it in stock. It sort of depends again on your shop. If everybody is very well trained, excuse me, if everybody is very well trained, you need fewer descriptions here. But if you are ISO 9001 compliant, you make sure that your processes ensure that the job gets done right. You ensure that. So sometimes that's done by writing a lot here. Sometimes it's mill per print, and the print has lots of stuff on it, the drawing. Sometimes it's mill per shop standard ABC that tells you feeds and speeds for different materials and things like that. So, and sometimes you just have a thing on the wall that says who is well trained and can do things without supervision and who doesn't. So, how you meet good process control standards, there is no right way. Okay. But you have to have some organized structure. So, this description is more or less complex depending on how you're structured. If you have a lot of good background material, maybe you only hire union certified journey level machinists. They're pretty well trained. You know, they've been through classes and apprenticeship and years of experience. They're sort of supposed to know how to clean a part. And so you don't have to tell them everything about it. And they're supposed to know how to machine things square. So you don't have to tell them about it. And they're supposed to know feeds and speeds with different color cutters on different materials. And so you don't have to tell them because they have training. They're certified people. Okay. Maybe you have a CNC machine that just always does the same thing, and this reference drawing refers to a program, and you just need somebody to make sure that the part is locked down so it doesn't go flying out when it's cut. And so but you've done work on your CNC program to ensure that it's right. So those are like two ends of the spectrum, and you can have everything in between. So your description has to make it clear what to do. And here's what's important. You need to get this in your annotations. And it has to be good enough to ensure that the processes that are gone through create the right part. Okay. So that's what goes here. And that was a lot, but you can go back and filter that down. We're doing labor hours for each little operation. How long will it take to saw my part? How long will it take to mill my part? How long will it take to clean my part? So this is the labor hours for each part. Now, this can get a little bit confusing because when I go pull my material, I do that once. And if I make 10 of them, I don't want to multiply by 10. But that's okay. We're not keeping track of that on this. We're going to keep track of that in another spot, in another place next week. So I just want to know, how long does it take to do this thing? For each part. Excuse me, I need a quick drink. Okay, and those you don't know. So I've made some examples here for you. To set up your mill, as an example, should take about 5 minutes, maybe 10 minutes. You do that once, and then it's already set up for all your parts. Okay, what is setup? Clean off the bed, put any fixtures on it, make sure that your cutters are there, load your CNC program, make sure that you have your cutting fluid all filled up, make sure the air is working so you can blow chips away. There's just a bunch of little things that you do. Okay. And then when you mill, when you actually cut, I put in 3 standards: inches per second, inches per minute, and inches per hour. Depends on what you're doing. Okay. And so you can imagine, how many inches do we cut? We cut 5, 5, 5, 5. That's 25, maybe 30 inches. So if I can do 3.5 inches per minute, it's going to take me about 10 minutes. Okay, so that's how you use these. You use those to figure these out. And then we're not doing this part, quantity in, quantity out. We're not doing that. Although you want to make this for, I think I said in the thing, 10 parts. But you're not doing this because this depends on what happens at each operation. And you're not filling this out because you're not the person who's making it. So this area right here, we're leaving it blank. This area, labor hours each, you do need to fill out, and you do it based on the standard operating times. If you have some operations that don't show up on here, add them in. You think of something that you need to do. Okay. So go ahead and add them in if you have some operations that you need to do. Especially since we're going to be talking about 3D printing a part, which I have on here. Maybe I have mill cut, but I don't have a turning cut on here. So if you have some things you want to put on, you can ask me. I'm going to put that on. What do I put in here for it? Or you can look it up and find out yourself how that works. Okay? But this information is used to calculate the information that goes in the labor hours. And it's just figuring it out. Okay, if I have so many inches on my part, what am I going to do? All that kind of stuff. Now, over here, inspection requirements, I don't need to inspect going and getting parts. So that would be no. I really don't need to inspect my saw cuts. Those are pretty simple. Maybe my milling cuts will be yes. Okay. Cleaning parts, I don't need to inspect that. Washing parts, taking them back to stock. So when I need an inspection, I'll do that. And then we've got reference drawings. This is probably going to be the same file every time for you. Okay. Sometimes you don't need one. If I say go pull 2x3 bar, you might put on the little drawing that you made of bar stock. Okay, if you made a drawing for it, but otherwise that can be blank. The milling cutter definitely needs one, clean. Wherever you reference things, your reference drawing goes here with a link and files. Okay, if you were to have a milling program file made and saved as something, you would list that here so they can pull that file and load it on the CNC mill. Okay, so that's the rest of. Any of you guys remember that old radio show? And that's the rest of the story. I don't know if any of you are old enough to remember that show. I loved it, and that's the rest of the story. Very cool. So that's the rest of the story, folks. Any questions at this point about what the work order is like and kind of how to figure it out and fill it out? Okay. Then here's what we're going to do. I'm going to go back and look. All of that, I think, was covered in the videos that were in the, I think those were all in these videos. Bing, bing. Okay. About work orders. And you can even see I had those funky little things and filling out all the little parts. Okay. And I talked about the standard timetables. They're all in there for you. What I want you to do, these ones are not nearly as obvious as like the purchase order template. So I'd like some really nice annotations that sort of explain the purpose for each of those columns and what they do. Okay, let's take a look and see. Let's talk about, and we talked about labor hours. Oh, data validation. Let's look at data validation. Here's my copy of the work order. And what you can see is I can actually go and select from a known bit of stuff of what I want to do on this work order. So how do I do that? I'm going to take the work order template and I'm going to create my own another new copy of it. Copy of the work order template. And I'm going to put it somewhere else. Now I'll put it in there. There it is, but I'm not going to share it with you. I'm not going to share mine with you. I'm going to restrict this. All right, so you can fill this stuff out. It's not too hard. I think on quantity ordered required, we put 10, and I think your work order is going to have 10. And you can put in your own name for the shop lead if you feel like it. And these are usually, I'm going to write justify it because it looks better. You can fill this stuff in, okay? But what I want to show you mostly is how to get these operations, what they are. And rather, oh, you know what? I'm not going to put in just an operation number. I'm going to give these operations a name. How do I do that? The first thing I want to do is this is my work order. And I've got some standard operations. So usually these have a number also. So I'm going to call this one 10, 15, I'm going to call this one 20. Call this one 25. 30. And these are usually set up by manufacturing. So I'm going to take a copy of that and I'm going to put it on a new sheet. I'm going to put that under operations. And I can make these bigger or smaller. It doesn't really matter. Okay, so those are just there for me. Now here's a cool thing. If I want to be able to pick those, I just want to, instead of going back and forth, copy, paste, copy, paste, copy, paste, I want to pick from a list. Google calls that a data validation, where I'm going to pick from a list of in a range. And I can make a list of items. I can do all sorts of stuff here. But my normal one is I'm going to pick a list from a range. And what's really cool, I can do that to all of these all at once. So I highlighted all of those and I go up to my data bar and I'm going to do data validation, a list from a range. And now I'm going to go click on this little grid and I'm going to click in the select. And now wherever I select works. So I'm going to go over here, operations, and that's what I want to select from. I want to select those. Now look what happens over here. These little arrows come up and I can, oh, I'm going to do setup first. Actually, I'm going to go get raw stock. And then I'm going to do my setup. And then I'm going to mill cut inches per minute. I might have some tooling change in there, but I don't think I will this time. So then I think I'm going to clean my part. And then I'm going to inspect my part. And then I don't have, do I have, I just have pull stock. So I don't have put back in stock. When I don't have, I forgot to saw my stock there. So I can see which ones have been done. And these numbers then just allow production control to look at numbers rather than the thing. Now I can do the same thing with my list of operations right over here. Where am I going to do those? I'm going to, some will be in the stock area. Some will be on the shop floor. Some will be in inspection. Some will be maybe in shipping and receiving. Something like that. So I can do the same thing on these work centers. I could give those numbers also. I'll do my data validation. I'll go find my new range, click. And this is my new range that I want to look at. Isn't that the coolest thing? Now, where is that going to pull stock? Is from the stock area. Saw cut is the shop floor, the shop floor, the shop. See how quick and easy that becomes? Inspection is in inspection. And so I can just keep going on with that. So these are really nice. Okay. A lot of times people will want to see the whole thing and they'll do something like that. Okay, there's all sorts you can do once you get these templates made to sort of get them into shape. Okay, and this would be a work order template for this part. So you don't have to fill this all out every time. So you would have a work order template for your block housing, and every block housing is kind of going to get done the same way, no matter how big it is. And this is going to tell you all the details of it. So this production control is always about efficiency, efficiency, efficiency. Okay. So there we go. I just wanted to show you. I just think these data validation, and watch this. I can even change this in location 20, location 30, and I don't care what you do. You can put numbers down. You can not put numbers down. Why didn't those change? Those should have updated over here. Oh, I have to go back. So those actually put the numbers in. So I have to go back and redo those. Cool, huh? You might even have common descriptions that you always use. Might have manufacturer per print, saw to length, print. Print. So there's all sorts of things that you might put in there that go with these. And you can even do that if you want. And they're just nice, easy ways so that when you've got a template, you can make some quick changes. So that's data, validation, select the range, and then you have to go find it. And click OK. Okay, so this one, I didn't put one in for that. How do I fix that? I didn't put one in there for it. So there's either often there's a BOM or something, but watch, it still doesn't show up when I come over here. So I have to fix this data validation. So it's the wrong range. I have to add the new one to the range. And then I have to add that all the way down. Okay, so somebody's going to give them a bill of material number, and they're just going to go pull that stock. Okay, so they have to be able to read it. Okay, so there we go. I think let's see what else I was going. Oh, I was going to go over the milling commands. So let's look over the milling commands. So when you run your program, I'm going to put this up side by side. Whoop, didn't work. You can see that there's some things for me to do. Okay, and this is the Sorry. Okay, well, I've lost my command list. There we go. That's what I want. I want my command list. All right. So there's certain things that you can do. I noticed from here that I had to enter fast travel mode. So I did a command called set mode. But since I have set mode fast travel and also powered cut, I have two commands, set mode 1, set mode 2. And so when I type in set mode 1 and the machine sees that, it's automatically going to pop itself into fast travel. And when it sees SM2, it's going to turn on the milling head and change itself so that its maximum speed is whatever I've set. Okay. And actually, I see that these are not quite right, but ours has fixed set speeds. Okay. Set maximums. So I can enter those. If I want to set the cutter size, that's like doing a tool change. I have to tell it what cutter I'm going to use. Okay. When you did it, you went up there, click, click, clicked on the right one. Well, if you're going to tell a machine, you have to give it a command. And there are things called compilers that read this command and look in the machine and actually give the machine the bit by bit commands to travel to a certain spot, let go of one cutter, grab another cutter, go back to another spot. I actually learned how to do that in 1985, I think. I did EEPROM programming for machine tools. And literally I was doing zeros and ones, zeros and ones, zeros and ones to make machine tools do what we wanted them to do. Okay, but this is a high level language. Okay, so if I wanted the 25 millimeter cutter, I would type in SC5. When it comes to zero the head, right, I've moved it over to here to zero the head. I type in RZ0, bink, it'll do that. Now, how did I get over there? I'd actually press the buttons, the buttons. So I need some sort of a manual travel that says when I'm pressing the button, go in X. When I'm pressing the button, go in Y. So that gives you a manual travel mode, and there should be a manual travel button on your controller that you can use. But if I tell it to travel in the X direction to a certain coordinate, I can type in the command TTX, travel to, in the X direction, some X coordinate. And if I want to travel in the Y direction, I can tell it travel to, in the Y direction, TTY. But I'm going to have to write my command as TTY underscore and some number. Okay, so that's pretty much your list of commands that you're going to need to do. Okay, now there's one other that you can set your percent speed. Okay, so you might fast travel. Let's say I wanted to go to fast travel to 2.5. I might set, I would say, set mode, fast travel, set speed, SS1 underscore 100 for 100%. And then I'd say TTX or TTY, maybe 2.25. TTY 2.25. And then I want to slow down. So then I would say set speed, SS1 underscore 10%. And I would say TTY 2.5. And it would go that last little bit very slowly. Okay, so this just allows you to do one thing at a time. One thing at a time, one thing at a time. And your job is to write a set of code using that. Okay? Any questions on that? Alrighty-o, then that is lecture. I'll get this posted in a while. I'm going to go ahead and turn off the recording.